Number 4. Look at it. Lincoln, what do you have for 4?
I have 0.
Okay, that's right. It's a constant. 6, Connor?
I got
7 over 2x minus 3.
Sorry, I'm having these technical problems here.
Dr. Barton, I love my notebook. I'm sure you have my homework on too.
Yes. This thing is not working. Okay, we're just going to have to go through it like this. It's not. 6. Did you say 6? I didn't
Yeah,
hear
I
you.
said the 7 over 2x minus 3.
Okay, 8. Naomi? Good. 7t to the 4th minus 5t. 10. Connie?
6u plus 6 minus 10. Or just plus 5.
Yeah, 6u plus 5. Lincoln? 12.
I have C 6 over y to the 5th.
Should be negative 6cy to the negative 7th. I think when you subtracted, you added instead.
Yeah.
12. Jessa, 14.
No. 5 over 3x is minus 2 over 3x 7.
Okay. I think you said that right. 5/3 x to the 2/3 minus 2/3 x to the minus 1/3. 16, Tori.
I have 1 over 4t to the 3/4 minus 4e to the t.
Good, and this is a negative 3/4.
Yeah, I have on.
Okay, good, I get it. 18, yeah, that's how I have it here. 18, Connor.
Y equals 2 plus 4x over 3. The square root 3 of x squared.
Okay.
That's hard.
Okay, so we bring down the 2/3, we get x to the minus 2/3. We bring down this, we get x to the 1/3. Now you can bring that down 2/3 over x to the 2/3, 4/3 x to the 1/3. $20, Samuel.
I have 8 mile.
Good. If you have any questions, let me know. 22, Naomi. Okay, it should be this. So negative 3/2 x to the 5/2 minus 1 over x squared. So we brought down our minus 3/2, subtracted 1, got minus 5/2, brought down the negative 1, subtracted 1, got negative 2. Connie, did you get 24?
I got 1.25 over 2 to the 1/2 plus 3.5.
So we had this radical 5. So I don't know what you do with your radicals, but so we get radical 5 over 2t to the 1/2 minus radical 7 over t squared, which is the same thing as this. So if you didn't get it, just fix it. Are there any questions?
On number 4, I forgot why into the fifth is
What?
like why is into the fifth?
Because it's a constant, and derivative of a constant is 0. E to the x is not a constant. E to the 5th, e is just a number, so e to the x is not a constant, it's a function, but e to a power is a number.
So easy number.
Yes, just e is a number. E to the x is a function. Tori, do you have 26?
I got e to the r plus e r to e minus 1.
Okay, good. I have all of this. E to the r plus e to the r minus 1. And then yeah, that's right. That's all there is to it. Okay. We've got something else here. I was distinguishing here between e to the x and x to the e. X to the e is the power rule. You bring down the e, x, e to the e minus 1, but this is a different thing altogether. Okay, 28, Tori. Oh wait, I did. Jessa.
I got negative 2a over z to the third minus b over z squared plus c.
Okay, so for 28, you first divide out your z squared, so you end up with this. And then we take the derivative of this, so we get this. The c is a constant, it goes away. So then we take the derivative of this, we get minus 2 over a minus b over z squared. Okay, how many of you got it? Lincoln, do you have 30?
It came out to be negative 19 over 64 t to the 6.
Okay, so let's go through it. 4t cubed is the same thing as 64. 4t, the quantity cubed, is the same thing as 64t cubed. Okay, so that's what's in your denominator. So now you have 1 plus 16 squared divided by this. So when you divide out each term, and we're dividing by this, we end up with t to the minus 3 over 64 plus t to the minus 1 over 4. And then we have to take the derivative. So we take the derivative of this, we get minus 3 t to the minus 4 over 64 minus t to the minus 2 over 4. Did anybody get it? That one was harder because you had to divide it out. But we did a couple of those. If you didn't get it, just fix it.
Go.
32. Violet.
I got x plus 1 e to the x.
Okay, so 32, you had to understand this one, e to the x plus 1 plus 1. Okay, so if you, e to the x plus 1 is the same thing as e to the x times e to the 1. Remember how we have like x to the 2 times x to the 3 is x to the 5th? So this is the same thing as e to the x and e to the 1. So we start out with this, where e is just a number. So I take the derivative of 1 that goes away, and then the derivative of e to the x is e to the x. And so I end up with just e to the x, which is the same thing again. You end up again with e to the x plus 1. Okay, so the 1 went away. We had only e to the x plus 1, but e to the x plus 1 is this. And this is the constant multiple rule. Derivative of this is e to the x. So we end up with the same thing, e times e to the x, which can be written like this. Did anyone get this one?
I guess, yeah, I just wrote it down, but I didn't know how to do it.
Okay, we're going to cover something called a product rule and the quotient rule. You also had in section 2.9, I gave you 52 to finish for homework. And did anyone feel confident in their answer?
I'll do.
What did you get?
A for acceleration, B for velocity, C for position, and D for jerk.
Okay.
Dr. Martin,
Yes,
I left my physics book in my truck.
it's okay. We're not going to be using it.
Jeez, on my phone.
Okay, so let's go through it again. You said D for the jerk.
Yeah.
Okay, now the one that is the jerk has no derivative. So when there's a horizontal tangent, there's no zero crossing. So if I look at that, which graph has a horizontal tangent but no other graph is crossing zero? What? A. If you look at A, you have those 2 horizontal tangents like this. And yet there's nothing crossing zero here or here. So A doesn't have any derivative. So therefore A has to be the jerk. Now, I also know that the position is not the derivative of anything else. Okay, so that might help you figure out where the position is. But let's just look at which one is the derivative of A. Sorry. We can go to B next, okay? So if I look at the horizontal tangent on B, right? We've got this curve like this. Which one is crossing zero as this reaches a horizontal tangent? Which one crosses zero? So if I look at B, which one crosses zero when B reaches a horizontal tangent?
C.
C isn't crossing zero there. C is the green one. Which one is crossing zero as B reaches that peak? A. Do you see that? You don't have your book open. No wonder you can't see it. We're on page 164.
Oh, it's a calculator.
So, okay, so I know that A is the jerk and B is the acceleration, okay? Because the derivative of B is A. So we have position, velocity, acceleration, and we don't normally deal with jerk, but jerk is the next level of derivatives.
What is jerk?
It sounds like they should name it something else. It's the derivative of acceleration. It's the rate of change of acceleration. Jerk, like something that jerks, like that. Okay. Well, everybody's here now. I don't need to record That's good. Okay, so let me shut off the video.